Okay, so let's talk about intermolecular forces. This is perhaps the most important concept in chemistry, and it goes across many fields. It goes into the fields of biology and physics and material science engineering. And it's basically how do substances form from molecules? How do molecules come together to form substances? It goes into the states of matter, it goes into the strength of materials. It's super important. So, how do molecules stick together? Intermolecular forces. So you're going to be able to rank the forms of intermolecular force based on the strength of attraction between molecules. And we're going to be able to describe real-life implications for these different intermolecular forces. So it basically comes down to whether a molecule is a polar molecule or a nonpolar molecule. That's going to determine the strength of the intermolecular forces. And so you'll need to be able to determine, is a bond polar by looking at the difference in electronegativity, and is the molecule polar by looking at the geometry of the molecule. So there are a few different forms of intermolecular forces. Combined together, all the forms that exist in a certain system are known as the van der Waals forces. But within those, there's individual forces, and they are ranked in terms of their strength of intermolecular attraction. So the strongest of those intermolecular forces is the ion-ion interaction. The second strongest is what we call ion-dipole. Then we have dipole-dipole interaction, dipole-induced dipole, and then dispersion forces, also known as induced dipole. Now what we're going to do is break down each of these five one step at a time and talk about what they do, how they do it, and some examples of what that looks like in the real world. This will be broken up into 4 videos that's going to break down these different interactions. All right, so ion-ion interaction is something we've already talked about. It's ionic bonding. It's basically the interaction that occurs when 2 ions come together and are attracted by those electrostatic forces, those positive and negative forces that come together. It is the strongest form of intermolecular force. And so things that are ionic, that have these ionic bonds, are very hard to separate. It is hard to pull these ions apart. It requires extremely high temperatures or many other stronger forces coming to overcome that attraction. So ionic substances usually have really high melting points. If you think about a solid where all of the atoms are locked into a position and they're not free to move, the liquid being a substance where these molecules are more free to move around each other, in order to be free to move, you're going to have to overcome the attraction that's holding them together. So it's going to require a lot of energy put into the system so that these ions have enough energy they can overcome that attraction and move more freely. So for instance, if you want to melt salt, sodium chloride, you're going to have to heat it up to more than 1800 degrees Celsius. And this picture here shows you a picture of molten salt. It's so hot that it's glowing yellow, even though the liquid itself is actually clear, but it's glowing because of the extreme heat. Next up on our list is ion-dipole interaction. What that indicates is that you've got an ion and a polar substance. So that dipole refers to having 2 poles, a positive side and a negative side. So ion-dipole interaction is the interaction of an ion with a polar substance. Perhaps the easiest example to give is the interaction between water molecules that are polar, that's your dipole side, and your salt, which is ionic. So if you were to place ions into water, what will happen is the water molecules will come in and surround the ion. So here's a sodium ion here, surrounded by water molecules. And even though ion-ion is the strongest force, if you get enough water molecules working together, they can pull that ion away from the crystal. Once they're in solution, it's hard to separate them. Like, have you ever tried to filter the salt out of water if you have salt water? It's not easy to do. It takes a lot of energy to force the water and salt molecules or the ions away from each other. It's going to require a lot of energy to do that. One way you can do it is to heat it up and evaporate the water. And you're going to have to heat it up to higher temperatures than just pure water, and you're going to have to move those water molecules away. Now, when you do that, the ions start finding each other again and start reforming those salt crystals that had originally dissolved. Okay, in our next video, we'll go over the next couple of different forms. So for this video has covered the two strongest, ion-ion and ion-dipole. Go to video number 2, and we'll learn about some more.